Good afternoon. Just check my voice is audible.
Yes, sir.
Okay, where the screen is visible.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Where we were?
Problem.
Problem. We were just solving the problems. Correct. Before that, we have seen what is the sign convention, etc. So for a given course, what is the sign convention? Getting. So quickly review what we have seen before that. Roll number 27 is there. 27. Just I want to ask few numbers. 27 and 37. Are you here? 27, 37, 39. Roll number 39. Absent. 41. Okay, I will check afterwards. All are absent. Sign convention. Let us see quickly. What is sign convention for this? How we have seen sign convention? If the force is upward and towards what? So that we can say it is positive force. Which force we are considering as a positive?
Upward or
Upward and right side.
Upward and
Right hand side.
Right hand side.
upward and right hand side. That force is
Positive.
positive. And which force is negative?
Downward and
Downward and
left hand
left
side.
Towards the left hand side.
Downward and
Left
Left hand side.
Left hand side.
okay. Then we have seen, I think, whether slide is changed. Slide. There is
No, sir.
problem, I think.
No,
No.
sir.
Just a minute. Okay. This one was our sign convention, as we discussed just how which force will be considered as positive and negative. Likewise, then we have seen resolution, how a particular force will be resolved into its component. So we have seen there are two components. We are going to resolve the force into two components which are perpendicular to each other. One will be along the plane with which inclination is given, and one will be perpendicular to it. Likewise, we have seen resolution. First we have considered the one force F, angle theta. Then for x component, the component which is along x axis, we have called it as a apex. The component which is along y axis we called as Fy. Okay. Then resolution of force. Just we found how we can, after derivation, application of trigonometry and etc., how we can find a component, horizontal component, vertical component, or x component and y component. So here we have decided one thumb rule. Whatever inclination or angle is given with the axis, along with that axis we have to take cosine function. If the angle is given with the x-axis, take along that axis component as a cosine function. If the angle is given with, suppose, vertical axis, then along that vertical axis, whatever component we are going to take, we have to take which function? If angle is given with vertical axis, then which function, sine or cosine?
Sine.
Sign.
If angle is given for a particular force with the vertical axis,
Cos.
Cosine.
cosine or cos, we have to take cosine or cos. In that case, we have to take cosine or cos. Okay. Here just that was only thing here mentioned how it is. Then we have seen what is this plus minus minus plus minus minus plus minus. What is this in this? So here actually a description of force resolved in different quadrant. What I have written that different signs plus minus minus plus minus minus plus minus. This one, what is this?
X axis and Y axis are positive.
What is
X
this?
component and Y
X component,
component.
Y component.
X component and Y component. More specific, huh? You are near to the correct answer, huh? What is this? Plus minus minus plus minus minus plus minus. What is this?
Component and Y axis.
Huh? Yes.
Component of X and Y axis.
Components of X and Y axis. I want exact answer. Let me know. Let us check who will give exact answer, huh?
Quadrant signs.
Quadrant sign. What is this exactly? What we have written? Plus plus. In first quadrant, both will be plus. What is that? Both.
In first quadrant, both X component and Y component are positive.
Very good. 99% correct. Plus plus means what? In first component, both X component and Y component, or more specific, sign of both component will be positive. Or on the other hand, we can say both will be. On the other hand, we can say both will be positive, or sign of both components. Both means which? X component and Y component will be positive. Likewise, it is there. What will happen in second? What will happen in third? Likewise, it is something like that. Okay. These are the signs of not coordinates. It is very basic. In first quadrant, X coordinate, Y, whatever it is, positive, negative, positive, negative, negative, positive, whatever. It is not that. What is this? These are the signs of components. X component and Y component. These are the signs. Plus plus, minus plus, minus minus, plus minus, in this way. So that should be the your answer. Okay, it is very basic. These are the signs of the components. If particular force will come in first quadrant, X component will be positive, Y will be positive. In that way, if particular force will come in fourth quadrant, X component will be positive, Y will be negative. In that way, you should tell the answer. Getting? After that, we have just here, whatever I have told, just it is shown on the figure. Just we have seen also this. If here it is mentioned now clearly, fx, fy. Fx is X component, fy is Y component. In this way, we have seen. First quadrant, both are positive. Second quadrant, X component negative, Y component positive. Third quadrant, both are
Negative.
Negative.
third quadrant, both are negative. What about fourth quadrant?
X positive,
X
Y
Positive,
negative.
Y negative.
X component positive, Y component negative. In that way. Further, forces in different quadrant, just it is shown. We have solved the problems also, so not necessary to discuss. Here also it is shown angle. So looking to this figure, what we have to remember, always while resolution of force, we have to remember, while resolution of force, we have to remember, acute angle. We have to take acute angle with one of the axis. It may be X axis or Y axis. So that should be the practice. That should be our practice to have or to get acute angle. Always we should use acute angle while in the resolution process. So then we have seen principal directions. How many principal directions are there?
Four.
Four. Which are they?
North, south,
South,
east,
South,
west.
east, west.
Okay. If force of 50 kilonewton is due south, if force of 50 kilonewton is due south, what will be its Y component?
minus 50.
Minus 50 kilonewton.
Zero.
15 kilonewton.
Zero?
No,
No.
sir.
No,
Minus
sir.
50 kilonewton.
Minus 50 kilonewton.
Minus
50 kilonewton.
minus 50 kilonewton. Still I got one answer, zero. I don't know from where that answer got. Just I asked a simple question. force of 50 kilonewton is due south. Now you should not imagine where is south. It is in front of you. Where is south? Is it upward, downward, RHS, LHS?
Downward.
Downward.
It is as simple as this. No, it is downward. That 50 kilonewton is going downward. And which component I have asked?
Y
Y
component.
component.
Y component. Then what should be your answer? What should be your answer then?
Minus 50
Minus
kilonewton.
Minus 50 kilonewton.
Minus 50 kilonewton should be the answer. Don't confuse. It is very simple. Next question. If a force of 100 Newton is due east, a force of 100 Newton is due east, what will be its Y component?
0.
Zero.
Zero.
It will be 0. It will be 0 irrespective of if it is 100 Newton or whatever. If it is horizontal, due east means horizontal. For horizontal, can we say in other words, for a horizontal component, it's for a given horizontal force, its vertical component is 0. Can we say like this? Can we say like this? In other words, for a horizontal force, its vertical component is 0. Can we say like this?
Yes,
Yes,
sir.
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 Definitely,
sir.
yes. Definitely. Means, in other words, we are saying if force is along x-axis, its Y component is 0. On the other hand, if force is vertical, what will be its vertical component? If force is vertical,
Value of force.
very good. Value of force or that force itself. In other words, more simple language. If force is vertical, what will be its vertical component? That force itself. Only we have to see sign. Is it downward or upward? Okay, in that way. So likewise, very basic questions will be asked in your very basic. These are very, very basic questions will be asked in your exam. So whatever. Okay, so that you should take care. So this one is one method to represent the force as far as principal directions are concerned. Okay, so due east, due west, due north, and due south. Due means what? Towards. Just I have written on the slide also yesterday. Due means towards. Due means towards. Likewise. Okay. Further, here, what is this? Numerical on resolution. So numerical, just whatever formula we have seen, that only we have to apply. The angle with whom axis it is given, along that axis or surface, we have to take cosine function. Again and again I am repeating this thing. Then we have started to solve problems. Okay, it should be there in your notebook. I hope it is there in your notebook. So we have solved a few problems yesterday, very simple problems. Only we have to imagine in which quadrant that force will come. How we are going to know in which quadrant that force is going to come? How we are going to come to know in which quadrant that force will come? एखादा फोर्स कुठल्या क्वाड्रंट मध्ये येणार आहे हे आपल्याला कसं समजेल? How we are going to know?
Its nature.
Along the
Direction of-
line of action of force.
Direction of line of action.
Very good. Someone says direction, someone is saying what?
Along the line of action of force.
Loudly, along
The line of action of force.
line of action, or depending upon line of action, where it is going. Okay, and direction of line of action, we can say, simple. So we solved certain problem. So this problem, this first was arrow is here. So in which quadrant that force was coming?
Third
Third.
quadrant.
Third quadrant.
quadrant.
Third we have seen. Okay, so there is no question about this. Further, what is this? 30 kilonewton. Okay, 30 degree. Just how it is. Alternate method. So what was there in this method? What was there in this method actually? What was there in this method? What was there? Alternate method. If here actually inclination of that force was given with the vertical axis. So what was in alternative method? It is told that you can find that that inclination with horizontal axis and you can proceed. Not necessary what I told. It may be one of the alternate method, but always it is not feasible to find angle with always horizontal axis. In each and every case, it is not feasible to find always angle of force with the horizontal. That's why what we have to do, whatever it may be axis, horizontal or vertical, okay, whatever inclination is given, we have to take along that axis cosine function and we have to proceed. That's all. Not necessary to calculate. If with vertical is given, then go for horizontal. It is not required. It is not required. Your answer will not change. Definitely, you have to continue as it is. So that was the alternative method. Okay, so here I have told, if the angle with vertical is 30 degree, then with the horizontal it will be 60. Further, we have solved again some problems in that also. In which quadrant this resolve force of 500 Newton acting northeast? Here angle is not given, means how much we are supposed to take?
45 degree.
45 degree. This one is one second method to indicate force. This one is second method to indicate force in principal direction. So due south, due north, due west, due east. Likewise here also we can show in that way. Okay, so in which quadrant that this force is coming? First. That's why it's both components are what?
Positive.
Positive. That we have solved. After that, 800 Newton force was in northwest quadrant or northwest direction. Northwest direction. So in which quadrant it will come? And acting away from the point.
Second quadrant.
Second
quadrant.
So what are the signs of components in second quadrant?
X
X
component
component
is
negative,
negative
Y
and Y
component
component
is
is
positive.
positive.
Very good. Next, 60 kilonewton force inclined at 200 degrees. How we have taken this 200 degrees inclination? With whom we have taken, or with whom it is given?
With x-axis.
X-axis. How we have taken positive clockwise or anti-clockwise?
Anti-clockwise.
Clockwise. So once certain quadrants are acquired, so which type of angle we have taken? Acute. Whether we have taken acute angle with the x-axis? Yes, we have taken acute
Yes,
angle.
sir.
We have considered a acute angle for calculation and then we proceed. Okay. Then force of 40 kilonewton is inclined at 330. Similar ways, in which quadrant this force came? 330 degrees with x-axis. Acting towards the point. In which quadrant this force came? In
Second
quadrant.
second quadrant. So x component will be
Po-
negative.
Negative.
Y will be
Negative.
positive. That way.
Positive.
Positive.
Y will be positive. Sorry, Y will be positive. X will be negative in that way. Next, 20 kilonewton force inclined at 150 degree. In which quadrant? And acting towards the point. Yes, acting towards the point. In which quadrant it will come?
Fourth quadrant.
Fourth quadrant.
Which one? Which one? Which?
fourth quadrant.
Fourth
Fourth
quadrant.
quadrant.
In fourth quadrant. And what are the signs of x and y component in the fourth quadrant?
X
X
component
component
is
positive,
Y
Y
component
component is negative.
negative.
Very good. Next, 25 Newton acting southeast and away from the point. In which quadrant it will come?
Fourth quadrant.
Fourth quadrant. What are the signs of these components in fourth quadrant?
X component positive, Y component
Y
negative.
component is negative.
X component is
Positive.
and Y is
Negative.
negative. Very good. Next one. What was there in this? Resolve force of 100 Newton acting how many degree? 35.
5 degree.
From where to where?
west to south.
West to south.
West to south, acting towards
Away
or
from
away from
the
the point?
Away
Away
from the
from the
point.
point.
Away from the point. How we have taken this 35 degree inclination of the force? How?
West to south.
West to south.
from west direction towards south direction we have taken that, and then finally in which quadrant this force came?
Third quadrant.
Third quadrant.
Third quadrant. And what are the signs of force in third quadrant?
Both are negative.
Both are
Both
negative.
are negative. Very good. Let us see now. Up to this we came. What you are observing on the screen?
Moment of the
Moment of the
force.
force.
Moment of the force. Okay. So write down next one. Moment of the force. Moment of the force. Okay. I will ask here. There are three terms. Okay. One is moment. Okay. Another one is momentum. Okay. And one is this movement. Any other term which you feel all are same? So this one is one, this one is another one, and this one is another one. Okay. So moment, momentum, and movement. What is this? Can anyone able to tell the difference between these three terms? Okay, forget about this. This we are going to see. What is this? Already we have seen second thing, second one.
Product of mass and
Mass
velocity.
into velocity.
Mass into velocity. Is it scalar or is it vector?
Vector.
Vector quantity.
Vector. Are you sure?
Yes, sir.
Are
Yes,
you
sir.
sure?
Yes, sir.
Yes, sir.
Okay, very good. It is vector, product of mass and velocity, mv, we can say. What is this third term?
halchal.
Very good. Movement. So it is not related to our technical work, technical things, we can say. So whatever you have told, it is correct. So if we are not at all Marathit सांगतो हालचाल, movement म्हणतो आपण. Okay, in that way. So it is not related at all with our terms. Only these two terms are related. Out of that you are knowing well these terms, so it's better. So this I will erase. This second term is also you are knowing. So this it is also good thing that you are knowing this. Okay, momentum. So now we will see moment. So what is movement? You can write in your notebook. What is movement? It is the rotational effect produced by the force on the body. It is rotational effect. It is rotational effect produced by whom and where? By whom? Kuni produced केला है
By force.
Force.
It is the rotational effect produced by the force on body. On whom? On body. By whom? By the force. And what? Rotational effect.
Rotational.
Rotational effect. In that way, it is the rotational effect produced by the force on the body. It is called
Moment.
what? I heard a pronunciation like movement.
Moment.
Moment. Moment. We have to say simply as a moment, not movement. Movement. That pronunciation should not be there. A moment. It is a rotational effect produced by the force on a body. Okay, so moment of a force about a point is the product of magnitude of force and the perpendicular distance between the point and, most important term, line of action of force. So simply maybe in your further technical interview, etc., the question may come, what is moment, how it is calculated? Or students are, instead of giving an answer as a, actually first line answer is correct. What is moment? It is nothing but rotational effect produced by the force on body. Rotational effect produced by the force on the body, it is moment. But students are telling force into distance. Force into distance, not displacement. Force into distance is moment. So it is very vague answer, I will say. General, very general answer. Moment, suppose I will indicate by M. So force F into, let us say distance is D. So it is very general, very general answer. Force into D. So what is magnitude of force? What it is saying? Magnitude of force. It is the product of the magnitude of the force and the distance. But which distance? Distance perpendicular. Perpendicular distance between the point and the line of action. Means suppose there is one force is acting on a body and we want to take moment at particular point. We want to take moment at particular point. Getting? Okay. We want to take moment at particular point. There may be many points where we can calculate the moment. For object, it is not the like case that we can take moment at only one point. There may be number of points, and this moment means what? In short, moment means what? Rotational effect. Moment means what? You remember hereafter. Moment means rotational effect produced by the force acting on body. In short, you can tell moment is nothing but rotational effect. In short, so it may be different to different point. We will see while solving problem. It may come, it should come, not may. It should come different at different point. Okay, because why it should be? Why it is so? Moment due to one force will be different at different point. Suppose I will draw here one diagram, something like this. Suppose A, B, C, D, and suppose this force is applied here at point certain, not at D. Or okay, it is at point D. It will say at point D here, somewhere here. Okay. So if you will take effect of this at point A, B, C, remaining 3 points, it will be different. Whatever that rotational effect, that is movement will be there, it will be different. Why it is so?
Because distance
Distance changes.
Very good. That I was expecting. Though the force, this F quantity is remaining same. What it is changing while calculating moment? This
Distance.
Distance.
D is varying, or it is varying. D is varying. That's why moment due to same force, it may change or it should change at different point, because we are going to change distance. We are going to change distance, or we can say perpendicular distance, more specific perpendicular distance between the point at which we want to moment and the line of action of force. That distance is going to change. That's why moment due to same force at different point will be different. असे विचारलं जाऊ शकते. It may come in your multiple choice question. Moment due to same force at different point will be same, different, can't predict, none of the above. What will be the answer?
Different.
Different.
Very good. Very good. Different. It will be different. बऱ्याच जणांना क्वेश्चनच कळाला नसेल. The moment at different points of a body due to same force or single force, same or single, same we will say, due to same force will be body वरच्या वेगवेगळ्या पॉइंट मध्ये we will say at different point the moment will be different with same force. Though the force is going to same, distance is going to change. That's why there may be change. Okay. We have seen moment is nothing but rotational effect produced by the force. Then here in detail it is told how it is. Moment of a force about a point is the product of magnitude of force and the perpendicular distance between the point and the line of action of force, and the line of action of force. That we will see how it is. Okay. Then how it is calculated? How it is calculated? How it is calculated? Moment is equal to magnitude into perpendicular distance. So here we have to take magnitude of force, magnitude. Okay. So most important, in case of resolution, you should concentrate on sign of force. In case of resolution, suppose you want to resolve a force, then you have to consider sign. Here specific, here it is mentioned specific, but while calculating magnitude, while calculating moment, we should consider magnitude of force and the perpendicular distance. We will see, and the perpendicular distance. Okay, so this one is most important. Next one is unit. What is the unit of moment, as it is a product of what, which two things?
Force and
Force
perpendicular.
and distance.
Perpendicular distance.
So what will be its unit?
Newton meter.
Newton meter.
Newton meter, simple. Unit of force is Newton, unit of distance is meter. So unit of moment will be Newton meter. Okay, next, a force can rotate the body. Means once we are going to apply the force on body, that body may rotate in clockwise or anti-clockwise direction. That body may rotate in clockwise or anti-clockwise direction. That's why accordingly moment of the force can be clockwise or anti-clockwise. That's why we have to here what the way we have seen sign convention for the force. The force which is upward and towards the right hand side, we are going to consider it as a positive. Likewise, if that particular force, once it is applied on the body, if it will have a rotational effect in clockwise direction, then we are going to consider it as a positive moment. Here it is, positive moment. Clockwise positive, anti-clockwise
Negative.
So I think at this stage you should be able to identify which will be positive and which will be negative, or we can say clockwise or anti-clockwise at this stage. कुणाला प्रॉब्लेम आहे का क्लॉकवाइज म्हणजे काय आणि अँटी क्लॉकवाइज म्हणजे काय? So it should be there in your mind. हे तुम्हाला समजलं पाहिजे at this stage. Clockwise means घड्याळाच्या काट्याच्या दिशेने, something like this. How it rotates, what the way it is rotate. Nowadays due to mobile there is no question of clocks. Okay, it may be there, but you should see clockwise and anti-clockwise. Okay, so once a moment is this word will come in front of you, it is rotational effect number one, due to force acting on the body. Okay, that rotational means that force is going to rotate a body. That is rotational effect. It is moment. Further, moment is nothing but the product of magnitude of the force and the perpendicular distance between the point and the line of action of force. Okay, so what is moment? So here magnitude is told. So whose magnitude here we have today? Only here word is magnitude, but which one?
Force magnitude.
Force magnitude. Here we are going to consider force magnitude. Unit is Newton meter. A force can rotate the body either clockwise or anti-clockwise. So here I will ask a question: which moment we are going to consider positive and which moment we are going to consider negative?
Clockwise is positive.
Clockwise positive and anti-clockwise negative.
Is negative.
Clockwise is
Positive.
Positive.
clockwise is positive and anti-clockwise is
Negative.
anti-clockwise is negative. Likewise. Okay, so this one is most important. So have you noted down this? Only theory, actually here there is nothing, but we should remember this: clockwise and anti-clockwise, this direction. And also you should be able to identify how it is. Okay, in this way, how it is, clockwise or anti-clockwise. For example, suppose here there is something, this force. Okay, let us say I will say this point as A, this point as B, and force is applied in upward direction. Force is applied in upward direction. Force F. So what will be the rotational effect due to this force F at point A? So at this point, means how that object, this force will rotate. Suppose
Anti-clockwise.
Huh?
Anti-clockwise.
कसं
Yes, sir.
फिरवेल हे ऑब्जेक्ट, म्हणजे मी बी च्या ठिकाणी असा अपवर्ड फोर्स लावलेला आहे. अपवर्ड at point B I have applied upward force F and I want to calculate what will be the rotational effect due to force F at point A. How it will rotate?
Anti-clockwise.
Anti-clockwise. This object will rotate in this way. So it should, you should imagine in this way. So whatever moment will be there, it will be positive or negative?
Negative.
It will be negative. It will be negative, something like this. So we will see problem. We are going to see problem at that time. You should remember. Okay. Let us see next. Here some examples are given. Some examples are given actually. How we have to calculate. So what it is told, always we have to calculate perpendicular distance from the point where you want to be, you want to have what moment, where you want to have moment in that way. So you should calculate perpendicular distance between line of action of force and the point at which you want to calculate moment, something like this we can say. Examples are given here. How will be the, so here one turning point is given. Turning point is nothing but what, here I want to calculate moment at this point. Suppose point I will give name as again A, and here I will give point B. Okay, B. So force of 10 Newton is applied downward at point B. So what will be the moment at point A? So moment M at point A due to force 10. So what is our formula in this? What our formula says?
Magnitude of force into
What is the magnitude of
perpendicular
force?
distance.
10 Newton.
10 Newton.
10 Newton. So if I will ask for that force, what will be X component and what will be Y component? For force 10, X component and Y component, how this
X
10 Newton
component
force
0.
is?
Y is minus 10 Newton and X component 0.
Very good. Y component is minus 10 Newton and X component is
0.
0. So let it be. So in that we have considered where Y resolution, we are going to consider it sign convention. But while calculating moment, is it necessary to consider it sign convention?
No.
No, sir.
So what only we have to consider for the force?
Clockwise, anti-clockwise.
Only magnitude.
How force will be clockwise, anti-clockwise?
Sorry,
That
sir.
effect
Sorry,
we
sir.
can consider. Okay, but for the force, which thing we have to consider? फोर्स आपल्याला फक्त काय कन्सिडर करायचं आहे?
Magnitude.
Only magnitude. Only we want to consider magnitude. That's all. So let us see. Okay. So 10. How this particular rod will rotate once I am going to apply the force at point B. How it will rotate? Clockwise or anti-clockwise? हा rod कसा rotate होईल? Clockwise or anti-clockwise?
Clockwise.
Clockwise. Then clockwise moment, whether we are taking positive or negative?
Positive.
What will be the perpendicular or minimum distance? Minimum or perpendicular? Same. Between line of action of force and the point at which we want to moment. At what point we want to calculate moment?
At point A.
Very good. At point A. And what is the shortest distance or perpendicular distance between point A and the line of action of force? That is point B. How much it is given?
0.50 meter.
0.50. So what will be this? Very simple.
5.
Simplest.
5
meter.
5
Newton meter.
5
Newton
Newton.
meter.
meter.
5 Newton meter. In this way, simplest. Likewise, we are going to calculate it. One is very simple, but we can going to calculate. Don't worry. In this way, we are going to calculate. Okay. So just a few examples are given. Person A, person B. So here 5000 Newton, and here what will happen? Just check here. So this activity, there are two persons sitting. What it is called, I don't know exactly, but you can see in this. What will happen? If you'll see the moment. So here distance is 2 meter. Here it is 1 meter. So whatever force is applied by him, it is 100 Newton, and here it is by 500 Newton. So what will be the moment at point, means rotational effect, that particular object? काय म्हणतात त्याला माहिती आहे? Somebody is knowing?
Seesaw.
Seesaw. Okay. Okay, good. I know. I got new word today. Very good. So what will be the rotational effect? What will be the moment due to this force?
Clockwise.
How much it will be? How much it will be? 500 Newton force, and what is the distance from that middle point, center point?
2 meter.
2 meter.
So 500 into 2, what will be it?
1000.
1000. So let us say Newton meter. What about this person? How much force he has applied? Are you able to see? 100, no, sorry, 1000. No, what is it?
1000.
1000 into 1 equal to
1000.
again 1000. Means, is there any rotational effect will be there?
No.
So if you sit in this way and apply the certain force, so whether that seesaw will make certain rotational movement, etc. Absolutely. At fulcrum, it is called fulcrum. Okay, pivot. At pivot, here that word is there. Okay, here it is. Here it is there. Whether it will make certain movement, it will remain stationary. Correct?
Yes, sir.
It will
Yes, sir.
remain stationary. Very good. Let us have a few examples on this to calculate the moment. Example number 1. So let us see. This one is first example. You can write in your notebook this statement. So statements are not there. You can write. Calculate moment. Calculate moment due to force 100 kilonewton. Due to force 100 kilonewton at point A. At point A. Problem number 1. I have written 1 there. Very simple. Have you written statement? Simple statement. Calculate moment. Calculate moment due to force 100 kilonewton at point A. Okay. And you can now here we have to neglect the thickness of rod. So that's why. So we are not going to consider thickness into our account, whatever it may be. So A point will be, suppose we are going to take here point A. So what will be that? Suppose MA will be the moment at point A. So what is the other definition of moment? Magnitude of force 100. So first you have to imagine whatever it may be the rotational effect in case number 1, whether that object will rotate clockwise or anti-clockwise.
Clockwise.
So you imagine, try to think on your own. Point A, how you can remember point A, you can imagine you hold you have hold point A in your left hand side. तुम्ही लेफ्ट हँड न पॉइंट ए ला पकडलेला आहे असं इमेजिन करायचं. यू कॅन इमेजिन लाईक दिस अँड फोर्स 100 kilonewton is applied at point B. Then how this object will rotate, that you have to imagine. हे ऑब्जेक्ट कसं रोटेट होईल, clockwise or anti-clockwise?
Clockwise.
It will rotate clockwise. Then clockwise movement, how we are taking?
Positive.
Positive.
Positive. So what is the formula for moment? Magnitude of force.
Magnitude of force
Force
into
into
perpendicular
perpendicular
distance.
distance. Magnitude of force is 100 into
4.
4
4.
equal to
400
400
Newton meter.
Newton meter.
Newton meter or kilonewton meter?
kilonewton.
Kilonewton meter.
Kilonewton meter.
Kilonewton meter. Simple, very simple. It one is very simple, not necessary to have a great knowledge. Just for with the beginning, we are taking a simple example so that you will practice. So you can do this because this will be a minor part in our further problems. This will be a minor part in our further problems in this way. So you can let us see how you will imagine. Next one. Similarly, problem number 2, I will write here. Problem number 2. Point B is here. Suppose let us imagine point B is here. Okay. Calculate moment due to force 300 Newton, 300 kilonewton at point B. At point B.
सर लेंथ कंप्लीट रॉडचं दिलेत ना?
No,
हा
it is
sir.
no, that length 2 meter length is not that for complete rod. That this length is up to for this. This length is for this only. For this to this. How much it will be? Simple.
600 kilonewton.
600 kilonewton.
Moment at point B equal to, let us write, I will write F into D. What is the value of F? 300
300
into 2.
2.
So it will be
600.
600 kilonewton meter.
very simple. Nothing else. Next. Are you imagining? Are you able to imagine how this object is going to rotate? So which thumb rule I have told?
minus 1000 Newton meter.
Minus. But third problem you are telling. Okay. You can solve. Very simple again. Third one. What is that?
minus 1000 Newton meter.
Minus 1000
Calculate
kilometer.
moment due to 200 Newton force at point C. At point C. So let us see this point we will take at here. We will take at this, no issue. And 200 Newton. So if you imagine, how to imagine that object is going to rotate either in clockwise or anti-clockwise?
Anti-clockwise.
Anti-clockwise.
Anti-clockwise. What you should do? You should imagine whatever at which point we want to movement. You imagine you have hold that point in your left hand side, left hand. तुम्ही तो पॉइंट लेफ्ट हँड मध्ये पकडलेला आहे असं इमेजिन करायचं. यू शुड इमेजिन लाईक दिस. देन यू हॅव टू चेक इट्स रोटेटिंग इफेक्ट. Then you have to check its rotating effect. So what will be here? What will be here? M at point C equal to our regular formula F into D. Value of F to, but it will be negative. It will be negative. So if possible, at the beginning itself, you will give negative. At the beginning itself, minus F into D. So what will be that? Minus 200 into 5 equal to minus 1000, no?
Yes, sir.
Yes, sir.
Newton meter. Very simple. So just for your imagination, I have put here very simple examples. Next.
minus
Minus
1500 Newton meter.
1500
Very good.
Newton meter.
So try to imagine moment at point D due to force 500 Newton, and whatever the distance is given, whatever that distance is given, so it is for like this. Okay. So here again I will write MD equal to we know again clockwise. It will have how it will be the have a effect, positive or negative, clockwise or anti-clockwise?
Anti-clockwise.
Anti-clockwise. So I will write F
Anti-clockwise.
into D equal to 500 into perpendicular distance 3 equal to minus 1500 Newton meter. Very simple. So likewise you will have very simple, just with the beginning how to calculate, because in earlier what we can say, in earlier problems we are going to have we are going to solve number of forces. For each force it may happen particular force is inclined, then we have to resolve that force into its component, horizontal and vertical. Then you have to find movement due to that horizontal and vertical component. Likewise complexity will increase. So don't be under wrong impression, such simple problems are there in our this subject. So this is just a beginning, that's why to imagine, I have given one thumb rule. At what point whatever you want to calculate movement, you should imagine that you are holding that point with your left hand side, and then you decide with this force is it going up clockwise or anti-clockwise, in that way. Okay, shall we go next?
Yes, sir.
Yes, sir.
Next. So just check whether answers are correct here. Actually answers were there, but we have calculated. Okay, so just check something gone wrong, something. I think all are correct.
Correct, sir.
All are correct.
Correct, sir.
Very good.
Yes, sir.
Let us see what it is there now. One exceptional case is there. Exceptional case, very important exceptional case, I will say, very very important. What it is there? Moment of a force passing through a given point. So exceptional case. Exceptional means what?
Zero.
Zero rotating effect.
Zero rotation.
Very good. That's what I was expecting. Very good. Zero. Now tell me why zero?
Perpendicular
Because force
distance
is
is one, sir.
perpendicular to distance.
What? Fast. What you are saying?
Force is
Perpendicular
The
distance.
perpendicular distance is zero.
Very good. Perpendicular distance is zero.
Zero.
That's why we know the definition of, very good, I am happy today. We know the distance force into D, but this D will become zero because that force is passing through point A. Force will pass through this point A. That's why it will not have effect. Are you imagining? If you are holding that point and you are just passing your force in from that point, then it will become zero. So if you will try to calculate, so here for your confusion this 4 meter distance is given, or let it be it is given. Are you going to use this 4 meter distance while calculating this moment?
No,
No.
sir.
No,
No,
sir.
just for in your, we can say, for confusing purpose it is given 4 meter, because immediately you will do 4 meter into 300, 100, 1200. It is wrong. Okay, so here we have to remember, remember, if, as we know, the definition of moment is force into displacement, force into distance, perpendicular distance. If I am going to what we can say, so just wait, if here straight line is not coming. Okay, if I am going to say, so this force will pass through this point, this force is going to pass this through this point, so its effect, this distance will become 0. So here 300 into 0, so it will become 0. Okay, so that is important. So here very important is what, if a given force is passing through point at what, at which we want to calculate moment, at that point it will be 0. If line of action of force is passing through a point at which we want to calculate moment, that moment will be 0. Why it is 0? Because the distance is 0. This you should imagine, because it will come again and again. Getting?
Yes, sir.
Yes, sir.
If line of action of force is passing through a desired point, आपण desired point म्हणजे काय म्हणू, desired point कुणाला म्हणूया, की जिथे आपल्याला मोमेंट कॅल्क्युलेट करायचं, त्याला आपण desired point असं म्हणूया. If line of action of force passing through a desired point, then moment at that point will be
0.
moment at that point will be 0. Are you getting? This one is most important, so you can note down your notebook. If line of action of force will pass through given point or desired point, then moment will be 0, or moment ड्यू टू दॅट फोर्स विल बी 0. त्या फोर्सनं जो काय रोटेशनल इफेक्ट होणार आहे त्या पॉइंटला तो काय असेल, 0. गेटिंग? अंडरस्टूड?
Yes, sir. Yes, sir.
So here it is, just whatever I have told, no, same is mentioned here. Same is mentioned here, that moment is 0. Hence moment is 0 because line of action of force in this way, moment is 0. Whatever I have told, line of action of the force passing through that point, that's why 0. Just note down this. What is the question here? Find
Moment of forces
Moment of
about
force about point B.
Find moment of force about point B. Where is point B? Here. Correct, no?
Yes, sir.
So what we have to do once we will see the problem. So we have to see in this particular object or in this force system how many forces are there. Then at respect to or at point B we have to calculate moment due to all the forces. Moment due to all the forces with respect to point B, and finally we have to add. That's all. हे असं करायचं आहे, म्हणजे पॉइंट बी ला चारही फोर्सचं मोमेंट काढायचं by considering very carefully distances etc, and finally just you have to add. Okay, so with this we will stop. I can understand it is your last lecture. Tomorrow we will solve this problem. Meanwhile, those who want to solve, you can, otherwise we will solve tomorrow. Please write your roll numbers immediately in chat box. We will stop for today. Thank you very much for joining. Please write the numbers. We will stop. Tomorrow we'll solve this problem.